In this section, we're going to talk about solving absolute value equations. So there's a couple of different ways that we can do this. One way is graphically, and the other way is algebraically. Let's start with graphically. It says here, solve the absolute value equation 2 times the absolute value of x minus 5 minus 4 equals 2. And I want to solve this graphically. So what I'm going to do here is I'm going to open up a graphing calculator or some other graphing utility such as Desmos. And then I'm going to graph the left side and the right side independently. So I'm going to do this on different lines. So the first line is going to say f of x equals 2 times the absolute value of x minus 5 minus 4. And what that's going to give you is this red V-shaped graph here. And then the second line, I just want to say g of x equals 2. So the left side is that 2 times the absolute value of x minus 5 minus 4, and the right side is that 2. Well, what that's going to do is that's going to create this horizontal line at y equals 2, and these are going to intersect with each other. And so they intersect at the points 2, 2, and 8, 2. And where these intersections take place, these x values are the solution to your problem. So in this case, solving 2 times the absolute value of x minus 5 minus 4 equals 2. Well, this is x equals 2 or x equals 8 as found from these points here, 2, 2 and 8, 2. So not much more to go off of there. Let's talk about algebraically. This is going to be a little bit trickier. So to do this, I've got 3 steps. Now, I want to think about in school, we usually want to avoid ISS, right? We usually want to avoid in-school suspension. Well, in this case, ISS is going to be a good thing. We want ISS. This is isolate, split, solve. I'm going to isolate the absolute value. I'm going to split the equation into a disjunction, and then finally, I'm going to solve both statements of that disjunction. So my first one here, solve the absolute value equation 2 times the absolute value of x minus 5 minus 4 equals 2. Now we already know the solution because we graphed it above. We know that x equals 2 or x equals 8, but let's see if we can do this algebraically. First, isolate the absolute value. So that means get this absolute value of x minus 5 by itself. To do that, I'm going to start by adding 4 to both sides and undoing everything that's happening here. So that's going to make 2 times the absolute value of x minus 5. This is equal to 2 plus 4 is 6. Now, we're not quite there yet. We're not isolated. We have to divide both sides by 2. So let's divide both sides by 2. 2's will divide out here. And you're left with the absolute value of x minus 5 equals 6 divided by 2 is 3. Now, at this point, the absolute value is isolated. It is by itself. There's nothing else around it. It's not being multiplied by anything. It's not being divided by anything. There's nothing that's added or subtracted to it. It is just by itself, that absolute value. So the next step is to then split this into what's called a disjunction. So here's how to do this. I'm going to split this, and the first one over here is going to be exactly as I see it without the absolute value symbols. So it's just x minus 5 equals 3. And then I'm going to say or, and then over here, I'm going to say x minus 5 again, so what's inside this absolute value, but this time equals negative 3. And then solve each. So if I add 5 to both sides here, I will get x equals 8. Or if I add 5 to both sides on this side, then I'll get x equals 2, which is exactly what we saw graphically. Okay, let's do one more of these. Solve the absolute value equation 3 times the absolute value of 4x minus 5, and then minus 2 equals 19. So those 3 steps again, ISS, isolate, split, solve. I'm going to isolate the absolute value by getting it by itself. So let's undo everything. Let's add 2 to both sides here. And that's going to give me 3 times the absolute value of 4x minus 5 equals 21. We're not quite isolated yet, so multiplied by 3, I'm going to divide both sides by 3. 3's divide out, and now I have my absolute value isolated. The absolute value of 4x minus 5 is equal to 7. And once I have it isolated, I can move on to the next step, which is to split this. So I'm going to split this into a disjunction. The first one is exactly as I see it without the absolute value symbols. So 4x minus 5 is equal to 7. And I'll say or, on the right side here, 4x minus 5 is equal to negative 7. And let's solve. Adding 5 to both sides. For this one, we'll get 4x equals 12. And then dividing by 4, I'll get x equals 3. Or, what happens over here? Add 5 to both sides. And we'll get 4x is equal to, this is going to be negative 2. And now, careful when you divide. When I divide by 4, I will get x equals negative 2 divided by 4. This is going to be negative 1/2. So there's how we use our 3 steps to solve absolute value equations. Isolate the absolute value, split it into a disjunction, and then solve both parts of the disjunction. So let's do a couple more problems. Only this time, what I've observed is we've gotten 2 possible solutions every single time. The first time we did this graphically, the second time we did this algebraically, same with the third time, but in all 3 we got 2 possible solutions. What about times when we'll have fewer than 2 solutions? Well, remember, isolate, split, solve. When we isolate the absolute value, that means everything. If we isolate the absolute value and we get something that's equal to a negative, there's no solution. Okay, so if you get the absolute value of, let's say x plus 3, and this is equal to negative 5, well, there's no solution there. If we isolate the absolute value and it's equal to exactly 0, so this time the absolute value of x plus 9 is equal to 0, well, then there's one solution. And just like the 2 above, if we isolate the absolute value and it's positive, then we know that there's 2 solutions. So let's check out these last 2 examples. Solve the absolute value equation, negative 5 times the absolute value of x plus 1, and then plus 2 equals 12. Let's going to solve this algebraically. Okay, so isolate. Subtract 2 from both sides. This is going to give me negative 5 times the absolute value of x plus 1 is equal to 10. I'm going to divide both sides by this negative 5. And I am now isolated. I've got the absolute value of x plus 1 equals 10 divided by negative 5 is negative 2. And according to my rule, if it's equal to a negative, there's no solution. Now, why is that? Well, very early on when you first talked about absolute values, you talked about how you can kind of use this for distance. Well, distance, there is no negative 2 feet. There's no negative 2 centimeters. There's no negative 2 miles. Okay, we would say that something is 2 miles away, but not necessarily negative 2 miles away. So here, there is no solution. Okay, we've got one more. Solve the absolute value equation. The absolute value of x plus 1 plus 2 at the end equals 2. We're going to solve this algebraically. Okay, so isolate, subtract 2 from both sides. Interestingly enough, these will subtract out and these will subtract out. So what's that leave us? The absolute value of x plus 1 is equal to 0. And my rule says that if I isolate my absolute value and I get 0, then there's only one solution. Well, why is that? If I tried to go to my next step, which is to split this into a disjunction, I would get the absolute value of x plus 1 equals positive 0, or the absolute value of x plus 1 equals negative 0. Well, there is no negative 0. There's not really even a positive. I mean, 0 is just neutral. It's 0. So that's why here I can ignore that. And I can just solve this over here. Oh, and when we isolate, I would actually not have those absolute value symbols anymore. Okay, so now let's just solve this. Subtract 1 from both sides. And we see x equals negative 1.